Hi students, today we are looking at the lesson Solving Systems Algebraically, and your learning target is I can solve a system of equations algebraically. For this lesson you will need 3 colors of highlighters or colored pencils, your choice. I will be using red, blue, and green, so you can follow along with me if you'd like to use those same colors. And then let's go ahead and just look at the definitions that you need to know. Substitute, just like any standard word for substitute, it means replace. And then your key to this is to look for a variable that is already alone, your key for this lesson, and you'll understand what that means in just a moment. For right now, let's go ahead and look at this simple example of 16 equals y and 2 times 8 equals y. So using those two equations, is there a way that you can replace a piece of one equation with a piece of a different equation to make it a new true equation? So what I'm asking is, can you take a piece of this first equation and a piece of this equation to combine to make one new true equation? Well, I can say that 16 equals y and 2 times 8 equals y. So if 16 equals y and 2 times 8 equals y, through the process of substitution, I can say that 16 equals 2 times 8. Do you agree? Because I took this piece, because this tells me that y equals this, and there's a y right here, so I took this and I plugged it into this y, and I've got 16 equals 2 times 8. Is that true? Yes, it's true. So I'm all set with that. Now, what this lesson is the same exact thing, only we're using equations and expressions, and we're using substitution, and we're plugging in the new solution for y into the original equation. So go ahead, if you have colors with you, I'm going to use red and blue. So right now you're going to need blue. Whoops, I don't need that big circle, sorry. Okay, so you're going to use blue. And I'm going to take this blue piece right here, right there, and I'm going to take it, and it says y equals this. And I'm going to look for the y up here, and I'm going to plug this in to my y. So now I'm going to have 9x plus 38 equals, and then what I had in black, just the original y equals, or 7x plus 10 equals 7x plus 10. Sorry, my cat decided to be weird. Unplug my computer. Okay, 7x plus 10. And then you are going to take this new equation and you can solve it. You have variables on both sides, so you just need to subtract 7x. Subtract 7x. And 9x take away 7x is 2x, plus 38 equals 10. And what do we do next? Subtract 38 from both sides. Subtract 38. So that's negative 28 equals 2x. Divide both sides by 2. Divide both sides by 2. X equals negative 14. Okay, so here's my x. Now remember, when I'm working with systems of equations, I'm looking for an ordered pair that's going to make my equation true. So this is just my x. This is not my final answer. I'm looking for an answer that's going to be an x and a y. And right now I only have the x. So I need to go through. I'm going to erase this, so if you need to still copy this down, please pause the video. I'm going to go through and let me erase this now. Okay, so remember that I had x equals negative 14 as my first answer that I found. X equals negative 14. So now I need to take this x, and through the process of substitution, I'm going to plug it back into one of the equations. And I personally am going to plug it into this equation, but you can plug it into either to find out what your answer is. So you'll have y equals 7 times negative 14 plus 10. So 7 times 14, I think it's going to be 98. Yes, so it's 98. Negative 98 plus 10 is negative 88. So y is negative 88. So your solution is, you've got an x and a y now. So your solution is negative 14, comma, negative 88. Okay, so knowing that we now know the answer, which is right here, let's go through and just review the steps that we took to get to this answer. So here were the steps to solve, and I've written them down the best that I could, but you may need to write them in words that make sense to you. So I replace the red y, which is right here, in one of the equations with the value of y from the second equation. So the value of y I put in blue. So my goal is to get rid of the y's or get rid of the x's so that I can have one variable to solve. So I got rid of the y's by filling in, by plugging in for y. So I had 9x plus 38 equals 7x plus 10. Then my next step was to solve for x and get x by itself, and I meant to do that in green. I'm sorry. I'll circle it in green though. So this was my green step to get x by itself. And then I'm substituting this x back into the first or the second equation, and I chose to put it into the first equation, which is fine. And then I'm solving for y and getting y by itself. Once I got y by itself, that should have also been in green. Then now I have my coordinate, and in my coordinate is x, y, where x and y are the two answers we found through the process of solving those equations. Okay, so if that doesn't make sense, that's okay. We have another one here to work with. This one, remember I told you the key was to look for a variable that's already alone. In this one, my y's were already by themselves, so that was awesome. This one, the x's and the y's are not by themselves. So what I'm going to do is I'm going to look through these equations and see, how can I get one of these variables to be by itself? And to me, this variable right here is almost by itself. It just has this stuff next to it. So I'm going to try to get this by itself first. So let's do that. And I'm going to use blue again to stay consistent. So I'm going to change this formula to get y by itself. So it's going to be y equals something. And I don't know what yet. Okay, so I need to, in order to get y by itself, I need to get rid of this 2x. This is a positive 2x. So I need to subtract 2x to both sides. A 2x, take away 2x, goes away. And I have on this side, I have negative y equals 6 minus 2x. 6 minus 2x. Okay, then this negative y is not by itself yet. So I need to divide by a negative 1, because if there's not a number here, it's just like dividing by a negative 1. Or multiplying by negative 1. So the opposite is dividing by negative 1. And then when I divide by the negative 1, it changes this whole expression into, I divide by negative 1, it changes this to a negative and this to a positive. So my final answer with y by itself is y equals negative 6x, or 6 plus 2x. Okay, and all I did was I took the information on this side and I tried to get y by itself by shifting it over to this side. Okay, so I have y equals negative 6 plus 2x, sorry. And now I have a variable that's by itself, which is perfect. So what I need to do is use substitution and plug in this value for y into this equation right here, into y. So I'm going to use red to do that. And all I'm doing is I'm taking the original equation, which is 3x plus 4y, but instead of doing y, I'm going to do 4 parentheses and enter this expression right here. So I'm going to use blue to show you that that's where I'm putting it. It's a negative 6 plus 2x. Okay, so that's where I put my expression from my second equation, and it's still all equal to 31. Now what I need to do is just distribute. So I do 4 times negative 6, which is negative 24. And then 4 times 2x, which is 8x, positive 8x, equals 31. And I need to bring down this 3x and the addition sign. Okay, so I have 3x plus negative 24 plus 8x equals 31. Now I just combine like terms. 3x and an 8x gives me 11x plus 24, or just minus 24, equals 31. And then I'm going to add 24 to get my x by itself. Undo addition and subtraction first. Add 24. That gives me 55 equals 11x. Divide both sides by 11 and you get x equals, you should get 5. Sorry, I'm writing all of this on an angle. I just now realized x equals 5. Okay, so I have x equals 5, and this is the part that I should do in green right here. I got x equals 5. This is part of my answer, but it's not my full answer. So I know that in my coordinate, 5 is going to be here. I still need to figure out what y is. Okay, so now I'm going to figure out what y is. Well, I've got what x equals now, so I just need to take this and plug it in to one of the equations, either this one or the other one. And for some reason, this equation looks easier to me, so I'm going to do that one. And all you do is, the original equation is 2x minus y equals 6, but instead of x, I'm going to put in the 5 that I just found out what x is. So 2 times 5 minus y equals 6. Okay, 2 times 5 is 10, minus y is 6. Well, you can tell right here, 10 take away a number is going to be 6. What is that number going to be? It's going to be 4. If you can see that, you can just know that it's going to be 4. If you need to solve it out, you can go ahead and solve it. But you can do 10 take away 4 is 6. Okay, so y equals 4. So my coordinate 5, 4 is my answer to this problem. Okay, so there's a lot of steps in these problems, but they go in the same pattern every time. So again, let's just review them one more time. You need to look for a variable that's already alone. If you've got one, great, go ahead and use it. It can be an x or a y, it doesn't matter. Then you replace the y, or the variable, in one of the equations with the value of y or x from the second equation. Then you solve for x and get x by itself. You substitute the answer x into the first or the second equation, which is what we did. This time I chose the first one. This time I chose the second one, but it doesn't matter. And then you solve for y to get y by itself. So you're looking for a coordinate pair, or an ordered pair for your final answer, your x and your y. Okay, so that is a lot of information to take in. Instead of doing practice tonight, all I want you to do is to write 3 sentences explaining how to solve a system of equations algebraically. You can write it here, you can write it on the back of the page, or somewhere in your book, but I want you to try to explain in your own words how to solve a system of equations, because it isn't something that just comes naturally to a lot of people. So please look over this, watch the video again if you need to, and come to class with questions, because we're going to be doing a lot of practice problems with this.